¿Qué tal? That's it. That's all my Spanish. Una cerveza? Okay, a bit more Spanish. So I came for the first time to Big Data Spain last year. Nobody is talking about graphs except me. Graphs. Look at the logo. It's a graph. Not a table, not a document, not a stream, not a batch processing, clockwork piece of bullshit. A graph. We won. Thank you for coming. It was a pleasure talking with you. Okay, so I'm going to talk about the boring title of my talk is Graphs and Fraud Detection in Finance. Actually, what I want to talk about are graphs, graph databases. I want to talk about criminal activity. I want to talk about social justice. I want to talk about politics, but I have to wrap it all up inside something vaguely technical. Stay with me. It's going to be a bit of a giggle, probably. Come on. Hardware. I have a partition problem in my network. Oh, no, I don't have a PowerPoint problem. Well, that almost never happens. Thank you, PowerPoint. There we go. So what are we going to talk about? Lots of fun things. How many of you guys are in finance? Go on, give me a good wave. How many of you think you should be in prison for what you've been doing? We have an honest guy at the back. Thank you, sir. So we're going to talk about several things, mostly in finance, all around the idea of using graphs for business intelligence, for good governance, for profit, for fun and profit. So we're going to talk about first-party fraud. We're going to talk about whiplash for cash, so insurance fraud in the auto industry. We're going to talk about payments and identity and how usernames and passwords are your granddad's technology. We're going to talk about master data management. We're going to talk about provenance of data. We're going to talk about counterparties and asset construction. And we're going to talk about governance. I think governance is particularly interesting in the light of the recent Swiss leaks scandal overwhelming the finance community. Anyone know who this guy is? I don't quite know the Spanish for this, but this guy's a dick. He's called Nigel, which is a dick name for a start. And he's got this, he's like a real right-wing, nutty politician in the UK. He doesn't believe in Europe. Like, I don't believe in the tooth fairy, but he doesn't believe in Europe. One of them exists, one of them doesn't. Anyway, Nigel's a dick, and he's going to be the basis for all of my jokes through this. So forgive me for the slightly Anglo spin, but I didn't know who your Nigel was. If I knew your Nigel, I would have used him. Anyway, first-party fraud, because Nigel is a fraud. What does the fraudster do? In first-party fraud, you have a fraudster or multiple fraudsters, and they behave initially like normal people. They apply for lines of credit with a bank or a lender, and then they act normally, they transact, they pay their bills on time. They seem like they're normal good guys. They get credit extended over time as a reward for their good behavior, and then suddenly, boom, they extract all of the credit and run away with it. In order to do this, in order to maximize the amounts of fraud they can commit, they create a network of synthetic IDs and take smaller lines of credit. They don't look for big loans that you will investigate deeply. They take small loans, hundreds or small thousands of euros, but they do it many times by using synthetic IDs. It's usually a hidden problem. As a normal person on the street, I don't notice this. But if you're in retail finance, so if you are dealing with the general public, this is really hitting your profits because these guys are clever and your data technology is shit. You are not keeping up with them. Shit being a computer science word that I learned at university. It's very, very, very sophisticated. So what? So actually, tens of billions of dollars are lost in the US banks alone every year, which as far as I can tell is about 2 bankers' bonuses, give or take. That is, let me put this in perspective, a quarter of all consumer debt in the US is written off because of this fraud. I will take 1% of that saving if you allow me to put this technology in your bank. So about 20% of unsecured bad debt across the European Union and the US is misclassified. Actually, it's first-party fraud. So this is deliberate fraud of the banking system by criminals. This is bad news. I don't feel sorry for the banks. They have plenty of money. After all, banks are buildings that are full of money and gold and jewels, like a pirate den, really. But But I do feel sorry for us as customers because ultimately we bear the cost of this fraud. These are enormous numbers. So how does it work? Well, the fraudsters make synthetic IDs. They create fraud rings. And what they will do is they will multiply the number of personas that they have by sharing addresses, sharing phone numbers, in order to exploit individual lines of credit, which they will then aggregate. Clever stuff, right? These people are not stupid. They are criminal, but they are not stupid. And then the fraud happens. Money moves from account to account. It's a revolving door strategy. It all looks fine. It's normal transactional flows from account to account to account. The banks reward this behavior by increasing the amount of credit each of these synthetic IDs can have. And then at some point, the fraudsters max out all of the credit and run. How do you detect it? Don't know. The collection process happens, so you send round the boys. Knock, knock, knock. Excuse me, sir. Are you Jim? No. Jim lives at this address with this phone number? No, I'm John. Sorry, can't help you. Because the fraudsters have made up all of these synthetic IDs. They don't relate to normal people who could be prosecuted. They may relate to real-world telephone numbers or real-world addresses, but you can't pin down these synthetic IDs to individuals easily. 2 fraudsters could rack up $80,000 or euros worth of debt. Multiply that up into an organized crime ring, and you can have many hundreds of thousands or millions of euros worth of debt written off every year, and you and I pay for this, right? It's not some hidden cost that the banks suck up. You and I pay for this. So we are being ripped off through the banking system by organized crime. This is what you do if you're in finance right now. You do discrete analyses on this. And what happens is that sometimes you find outliers in your data, and you investigate them. And I know this because I used my credit card in Spain, and I became an outlier. Turns out, I'm honest. But you guys persecuted me because I used a British credit card in Spain, and it looked like one of these. You know what? The fraudsters are in here, and we're not seeing them with discrete data analyses. With all the batch processing, stream processing, big data stuff that we have at our disposal, we are not catching the bad guys. So what do? You can't react in time. The fraudsters have already busted out and they've run. How do you know either how to stop a fraud in advance or how to stop a fraud when it's happening to limit your losses? You graph it, because these things are not discrete data items floating around in space. These are linked events. These are linked people. This crime is a network. And as nerds, we know about networks, right? Unless you're American, in which case, not so much, because your phone and internet is shit. So, on the other hand, this is why Americans make great databases. Because for them, network partitions are not an academic exercise. They are everyday life. How do they have Silicon Valley? It's baffling. Sorry. Here are some normal people. This is a graph of normal people. This is, you can see here that we have some people. These are the red nodes in this graph, and they hold some phone number together, so they have a home phone number. You remember those? They're from the 20th century, very retro. And they both live at the same address, and you can see here that they own individual lines of credit cards. And so this is a common pattern. Notice these guys aren't connected, right? They are probably cohabiting people, maybe man and wife, maybe domestic partners, flatmates, whatever. But you can see the pattern. It's a local, disconnected neighborhood. This is not worrying, because it's quite okay for people to live at the same address and even to have the same phone number, because people still have phones in their homes. When was the last time you wanted to phone a house? Anyway, legacy stuff. But this is okay. These are not fraudsters. These are probably nice people. And if you want to find them in the graph, you specify a pattern. This is Neo4j query syntax. It's called Cypher. So there's 2 things you should know about Neo4j. 1, worst named database ever. Because I call it Neo4j, which is already quite shit. You want to call it like Neo4j or something. It's just fucking awful, right? 2, Neo4j's query language is called Cypher. Cypher means opaque and impenetrable, which is the exact opposite of what we want it to be. So what you learn from this is that the Neo4j people cannot name anything at all. It's because they're Swedish. Strange people, cold place, you guys wouldn't understand. Anyway, this is Neo4j query syntax. And what this is saying is, hey, database, I want you to find me a pattern. And this pattern is ASCII art for graphs. So you draw the pattern that you're interested in, and then the database goes off and finds it for you. It's kind of nice. Even if you're just like a Visio architect. Come on, some of you are. Oh, shy, too shy. Even if you're just a Visio or PowerPoint guy, just like me, then you can still do this. So I'm saying, hey, database, find me a node, which is a person, which either holds a phone number or lives at some node I don't care about, where it's connected to another person who holds a phone number or lives at the same thing. Return me where the start person and the end person isn't the same, so it's not me. I'm not circling back to myself. Tell me P1. Now, that's just like drawing a graph. What's lovely about Neo4j is this and this. At any depth. Imagine doing that in a relational database. Recursive joins at any depth. Who feels safe at one join? Everybody feels pretty confident. Who feels safe at 2 joins? The sensible people have already put down their hands. 3 joins, now we only have mad people. 4 joins, you are certifiable, go get psychiatric treatment. It's never going to work. This in Neo4j, this works. Why? Because we're not set-based, we're not table-based. In the guts of Neo4j, in the core of the database, we do pointer chasing, an extremely efficient way of finding routes, paths through data. So in Neo4j, if you want to make arbitrary depth queries, fine, go ahead. The latency of your query is proportional to how much of the graph you choose to explore. It is not proportional to how much data is in the database. This is quite a departure from set-based processing, where as you add more data, all queries get slower. Graph databases, good graph databases don't do that. So anyway, I can find non-fraudulent people, which is nice. This is weird. How can all of these people have some shared phone numbers, some shared addresses, another shared phone number, another? This is weird, right? I mean, even student life isn't this complicated. And student life is quite complicated. This is weird. This is dodgy. I'm not saying these people are fraudsters, but this pattern is unusual and it needs looking into. If I want to find risky people right across my data set, I just specify the pattern. I'm like, hey, find me people who share an address or who share a phone number, and where I've got a chain of shared address followed by shared phone number, followed by shared address, followed by shared phone number at whatever depth I want. This is scanning across the entire data set. It's going to take several milliseconds to run because I've got a small data set. Even so, if you were to run this on a population of millions, it's still going to run in minutes. It's still going to be quick enough for you to do some deep analytics on this in a meaningful amount of time. But what's really nice about graph databases is if you find someone of interest, you can narrow down the query. You can say, hey, this person's Sol, I think they're dodgy. Does that translate in Spanish? Dodgy. Suspicious. Thank you. I never learned English, so forgive me for my poor use of it. It's true, I never did. Just people were talking English and the kind of osmosis, I don't know. You really want a Swedish person who learned English very precisely to give this talk. Anyway, we found this one person, Sol, who we think is dodgy, so we're going to run the same pattern against him, and suddenly we find in his fraud ring 5 fraudsters in half a second. This is on an untuned database. It's just something I did on my laptop for fun. If you were to do this on a real server in real production, that would be fractions of milliseconds. The point being, you can put this in between a web request and a web response. So if you want to fraud check every single one of my transactions, looking to see if I'm in a dodgy network, dodgy is your new English word of the day, it turns out, you can do that online right now and stop me from defrauding you, or stop Sol from defrauding you. So you can stop a bust out in milliseconds. If you then want to revoke it, fine. Instead of just finding these people, act on it. Delete them and delete their card. Done deal. They can no longer spend. So that's done. First-party fraud solved. I hope you're all sitting there Googling. Nigel Farage is his name. He's quite a fucking idiot. Swearing doesn't count in your second language, right? That's the rule. So only Paco is offended by this, turns out. But you shouldn't be, Paco. You shouldn't be offended. Swearing is slightly rude. Sorry, I do swear a little bit. But it's not as rude as carrying guns in public. So we're kind of... I've got to go to America next week. Don't publish this YouTube video before I get through immigration, please. So, auto fraud. So not only are we fighting fraud in the kind of retail, consumer loan space, we're fighting fraud on our roads. Whiplash, which doesn't exist in some countries, does exist in others, is an amazing, amazing opportunity for fraud. So the problem is that the medical problem is said that you have a car crash, you rapidly decelerate, your neck gets thrust back at a very, very high speed, and you get soft tissue injury, which is very hard to diagnose or therefore disprove. And therefore, you may be able to claim compensation for it because we're quite a litigious society now. So what happens is, prior to impact, you're fine. About 1/20th of a second later, your neck is thrust back. And about 1/10 of a second later, you've got snap, ow. And then about 6 months later, ka-ching. Now, I'm sure that I'm somewhat sure that there are genuine whiplash cases. But because soft tissue injuries are hard to diagnose, it's also a great place to hide fraud. So what happens in these cases is you have a fraud ring again. You have drivers, passengers, witnesses, providers like legals and medics and so on, and they collude. And what happens is, in these fraud cases, is that someone places a witness on the street, you place a driver in a car, and then you pick some poor member of the public, one of you guys, and you crash into them. Or you drive erratically so that it causes a crash. Then you get whiplash, and then you claim compensation. This happens all the time. Interestingly, there is a secondary market here. So as the driver, I've already set up my dodgy doctor and my dodgy lawyer and my dodgy witness, I will now sell to you the passenger seat. Sorry, where's the passenger seat in Spain? This side. It's kind of confusing. I will sell to you the passenger seat for 2,000 euros. Can you believe that? There's a secondary market in being in a fucking car crash for money. So you will buy this 2,000 euro passenger seat. You will get in. We will cause the crash. Our dodgy witness will witness it and say it's your fault. And my dodgy lawyer will attest to that. And my dodgy doctor will say, oh, awful whiplash, needs compensation. And the passenger who bought this seat for 2,000 euros will now make between 20 and 40,000 euros in soft tissue injury compensation. Brilliant! I mean, criminal, right? But kind of clever. You got to admire it, right? You know when you do that really shitty hack in your code, and you're like, oh, but you've got to admire the genius or the audacity of these people, right? So this is a ridiculously large problem. 80 billion a year spent on auto insurance fraud and growing. I will take 1% again of that cash saving and retire tomorrow, right? This is a massive problem. In the UK, we're paying about £100, about 120 euros a year, each of us paying 120 euros a year, give or take, additional on our driving insurance because of this fraud. In the US, it's nearly $300, almost twice as much, nearly $300 a year per driver spent just because of this fraud. I would like that $300 back in my pocket, thank you. Normal drivers look like this. We are a driver, and we drive a car. Right. I suspect you could do that even in Oracle. Not in DB2. So if I want to find out normal drivers, they're really easy. I say, hey, database, find me a person that drives a car where they haven't briefed a lawyer, where they have not been examined by a doctor, where they have not witnessed another car, and where they have not been a passenger in another car. Fine, that's all the nice people who don't cause accidents or commit fraud. Genuine claimants are probably also nice people, right? They have not committed multiple claims. It's just, now and again you crash the car, you have to claim on the insurance. I've done this. I ran over my best friend. He was on a motorbike. I was in a big 4x4. I squashed him. That was bad. I felt rather guilty about that. But, then we had a genuine insurance claim where I had to explain that at about 3 kilometers an hour, I ran over my best friend and damaged my car. And it looked like this, right? So you have You have a bunch of drivers that drive a car. You have individual drivers may have been examined once by a doctor or may have been briefed once by a lawyer in order to process their legal claim for whiplash or whatever it happens to be. But it's really kind of a one-off kind of thing. It's a pattern that we're not so worried about. If we want to look at it, again, we ask the database to find a person that drives a car where they've been briefed by a lawyer and examined by a doctor. We are also perhaps interested in any witnesses to the event and any passengers in the car. So we can return that very quickly from the database. So we're saying, database, find me these patterns that I'm interested in. That's really the heart of graph query. Fraudsters look different. Fraudsters are involved in far too many claims. They are involved, they're being briefed with far too many lawyers. They are acting as witnesses in other claims. They are using the same fraudulent doctor to prosecute their claims. Their pattern is distinct, and you can pick it out if you can visualize and query for this pattern as a graph. Here we're saying, oi, database, find me this person who drives a car, who's been briefed by a lawyer, who's been examined by a doctor, who's witnessed other incidents of cars, and perhaps even who's been a passenger in a car. Maybe you've bought one of those secondary market seats. So return them to me where the number of witnessed events is greater than 1, or where you've been a passenger in a crashed car more than once. So a real low barrier to entry there, real sensitive query. Return the people. Once you've got that, you can then explore the network, not just to find the initial fraudster, the driver of the car. You can extend through the network to find the doctor and get them struck off. You can extend through the network to find the lawyers and get them disbarred. You can also find their passengers who are buying these secondary market seats and get them prosecuted. And you can see this in milliseconds. So as someone phones into your call center and makes a claim for yet another spurious whiplash injury, you've already run this query and you know that they are a fraudster. You put them on hold, call the police, job done. In milliseconds. Not export, crunch, turn the handles. Sorry, this is, okay, sorry, streaming now so I can turn the handle faster. Sorry, that was batch. It's like a big sausage machine. Streaming is like that, but you can... It's like an interpretive dance, really. It's like... And you do it in milliseconds, and that's fast enough. And all you're doing is searching for patterns. Look at the screen, please. You will buy Neo4j. I have a baby who needs food. Buy Neo4j. All right, good. Now you're all tremendously hypnotized. Let's move on now. Thanks, Nigel. You are the gift that keeps on giving, friend. To impersonation, to phony personas. So online payments, fraud, and identity. We all use the internet for e-commerce now. We are all susceptible to having our identities hijacked, having our credit scores trashed, and having people steal on our behalf. This is a bad thing. You guys are probably fine, right? You can probably see obvious phishing attempts and you ignore them. You know, that email from Nigeria promising you 20 million euros as a handling fee, you're wise to that, right? Yeah. There's one guy at the back, wait, this isn't true? No, mate, it's not true, it's not true. So we're a little weird bubble. We kind of know this, we can probably avoid it. But for the vast majority of people, phishing is a real thing. My mum has been phished. Admittedly, it was quite a skillful fish. They'd gathered some publicly available data, and they pretended to be her bank. It was really, really cool. I fished my colleague. So, you know, they always ask questions like, what is your mother's maiden name? What was the first city that you lived in, and so on. So I turned to my colleague one day as he was typing his credit card number into the screen, which I then photographed, which then accidentally got streamed to iCloud. Oops. I said to him, hey, when you were living in Nottingham, what was your mother's maiden name? Which is a stupid question, but he immediately answered. Then he's like, wait a minute. I'm like, ha-ha. So it's actually rather easy to phish people. So what should we do, though, as service providers to protect against credentials that seem fine? Hey, username and password is fine, right? So it must be Jim. What about if it's a valid credit card number with a valid security code? It turns out these things are... This guy has the best job, right? He's got this like space-age gizmo, and he's like... But notice, he's been chasing speakers around for the last 2 days. This is revenge. fight, 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 fight. You know what this is? This is where the speakers hide from him. There's like 6 people back here cowering. Come on out, boys. It's all right. It's all right. He's gone away now. Where was I? Oh, yeah. How do we protect against this, right? This seems fine. Username, password, valid credit card, all that. The thing is, it's an awful thing to treat these things separately because they all compose fragments of our identity. We are all little stars. We are our username and password, but we are also our 2-factor auth on our mobile devices. We're our device IDs. We are our IP addresses or our tracking cookies or our credit card number or our PayPal account. Some gaming sites, particularly gambling sites, already do this. I know this because my wife has a friend, and my wife's friend has a husband, and my wife's friend's husband happens to be a financial trader. He also, that means a couple of things. Firstly, he likes gambling, does it for a living. And secondly, he has too much money. So my wife's friend gets it, my wife's friend's husband decides, as all financial traders eventually must do, to buy a racehorse. As you do, right? We've all got a racehorse or two stuck away at home somewhere. And then he decides that he's going to go and gamble online on his racehorse, which is naughty, naughty. And then he decides that he's going to tell his friend what to do. And his friend says, okay, can I use the computer that you just used to place a similar bet against your horse? How surprised were they when the gambling company not only stopped the bets, but tried to revoke his license as a banker? And they're like, but you can't do that. The internet is secret. No, we already do this. The technology is already there in some places. So we place tracking cookies in browsers. We look at IP addresses and device IDs. Etsy, the big arts and crafts platform, several years ago I talked to them about identity, and they were really advanced in their thinking, that for them, identity is a graph. It's made up of all kinds of things that they know about you, and they score the things they know about you, the claims, and they get a statistically good or bad sense of whether you are you. IP address, username, password, PayPal account, tracking cookies, a whole bunch of other things. And they decide based on a plethora of information whether you are you, not just username and password or something easily fished. So that gives us the idea of an identity graph. And for individuals, an identity graph is pretty simple. It's a little star, right? So you've got your username and password. You've got maybe an IP address that you often visit from, or a device ID because you're visiting often from an app on your phone. Maybe some cookies. Maybe you've got a PayPal account or some other third-party authenticatable stuff going on. So we're little stars, not just a username and password, but so much more. It's much stronger when you can use this kind of identity graph. But what do you get when you start to merge these things together? As an individual, it's pretty interesting. It will give me a much stronger sense of, that I'm authorized to do something. It gives the service provider a much stronger sense of my identity. But what gets really interesting is that you can weight all these, not just for me, but you can start to sum across my login history, and you can start to find odd things, different cookie, different device, different location, and indeed, you can start to sum across all of the identity graphs, because some of them are connected. Does this start to look familiar? Yeah, because it's the same synthetic ID fraud ring that we saw in the first-party fraud example. So as a side effect of doing diligent identity graph work, you actually get the platform for determining first-party fraud kind of for free. Because you can explore my graph, discover that I'm doing some weird stuff, like sharing a credit card and a PayPal account with some other guy, and decide whether that's permitted or dodgy in your world. And of course, because this stuff's now in a graph, it's trivial to spot these patterns. You say, hey, database, find me a pattern where people are sharing PayPal accounts, because I don't like that, and tell me about them, and I'll scrutinize their account more or do something. So in Neo4j, it looks like this. It's like, hey, these two, Jim and James, both own this credit card. That's weird, because credit cards are usually owned by one person, right? So we can explore, search for potential fraudsters. Tell me where some user has something in common with another user, but where it's not an internet protocol address. Because you know what? Many of us share IP addresses, particularly at home. When we're shopping through home broadband, we share an IP. That's not suspicious. So we can start to do that. We can start saying, hey, find where Jim shares stuff with other people and find other people who are in Jim's fraud ring. I really should have picked a different name there. I feel like I've incriminated myself terribly now. So this, again, you can do this in milliseconds. As people are interacting with your service, you can determine whether they're a fraudster, if they are a fraudster, the extent of their fraud ring, and then you can close down their account or subject them to scrutiny or whatever. This, I believe, is what Etsy is doing. If they find one part of a fraud ring, they can immediately traverse the graph and close down other parts of the fraud ring. Super important to them because they're a platform that runs on trust. That is their currency. If you are a bank, you don't run on money. Money is a derivative. You run on trust. If you lose trust, you go out of business. So how does this stuff fit in with Gartner's view of the world? Well, Gartner says this is at layer 5. This is the advanced clever layer, where entities are linked together and you make sense of connected data in order to ascertain fraud or not. This is the level where if you are working in identity or fraud detection, this is the level you want to be at, and graphs propel you to that level very, very quickly. There are about 2 native English speakers in the room. I will leave you with the sense that master data sounds similar to a rude word in English. And he is one. So master data, big problem for all enterprises. Finance, no different there. So what we want to do is provide high-quality reference data into business processes at the right time in the process. We want to bridge silos. Silos are a fact. And we want to bring them together so that we have a unified view of data in a timely fashion without disrupting the enterprise. If you're a database person, you're like, oh, this is just fancy indexes. Our point of view as a graphista is that you want a multi-dimensional view of your index. You want effectively a dynamic OLAP cube, or a cube of cubes, dynamic OLAP hypercube that spans your enterprise so you can always get a 360-degree view of me or other critical business information injected into your processes at the right time. Plenty of people are doing this. So sportswear manufacturer Adidas are doing this. They've got a shared metadata service that's a big graph. And what they're using that for is to give a 360-degree view of customer for recommendations and tracking trends and so on. It didn't have to be disruptive. It's built atop their existing systems and just injects the right data from those systems at the right time into the business processes to enable customers to be well supported. ICE are doing this. ICE are a trading platform. They're doing this to connect like-minded communities of traders together so they can unlock more liquidity, drive trade volume. Pitney Bowes actually has an MDM platform that you can buy and plug into your systems. So it's a commercial platform that happens to be built on Neo4j under the covers. So the kind of graph MDM thing is a really growing area. I'll give you a quick example. Recommendations. So this is the thing that ICE do with their master data, and what they want to do is connect people together. They want to connect traders together. And in graphs, in graph theory, there's this notion of triadic closure. It's a really simple thing, although the mathematicians give it this rather grand name. You know when Haskell people say monads? You know that, right? They don't just say monads, they go, monads! Like fucking Harry Potter or something, right? Graph theory people are a little bit like that. Like, they can't just say, make triangles. That just sounds too, I don't know, childish. So they have this fancy word, triadic closure! Boom! It just means make triangles. So don't worry, we'll simplify this down to my level. Make triangles. Funny thing about human networks, we want to make triangles. If you know Paco and you know me, and you vouch for us, you say, Paco's a good guy, Jim's a good guy. Chances are, we're going to intersect. We're going to meet each other and say, hey, yeah, this is cool. Eva vouched for us, and yeah, she's right, man, you're cool. Let's go get a beer. Let's go get a beer. There's a thing in human networks where we want to close triangles. There's a tendency in human graphs to close triangles because it's transitive trust, and trust is valuable. In the trading network, same thing. You want to trade with people you trust. So if you've already got a small network of traders, ideally what you'd like for them to do is vouch for other traders in their network so you can trade with them. And actually, that's as simple as making triangles. So given a network of traders, you can simply try to make triangles in that network, triadic closure, close the triangle. And from those closures, you actually get high-quality recommendations about who you should be trading with next. In these guys, what does that mean? Much bigger pool of liquidity. The liquidity graph expands in a trusted way because you're only dealing with people whose trust is already vouched for transitively. So boom, simple query, make the triangles, please. So hey, find me a trader, that could be me, or I trust another trader where a trader also trusts you. Where me and you aren't the same, because obviously I trust myself, so it's trust over here, then return me the trader. And suddenly I've got another trader who I trust because I trust you and you trust him, and we can start trading. So I can do that globally. I can scan the entire network and fill in all of the triangles, and I can do that iteratively and repeatedly and incrementally and get better and better and better recommendations. Or I can just do it for me. And when I do it just for me, within my web request, web response, I can get the next set of recommendations in my neighborhood again in milliseconds. So you can do this stuff in OLTP mode. This, by the way, was long since figured out by the graph theoreticians and published. The best example of this is published in a book called Networks, Crowds, and Markets by Easley and Kleinberg, which should be a boring book because it's this thick and it's written by academics, like with elbow patches and pipes and stuff. It's a really good book. Get it. It's the best book on graphs I ever read. It's not the best book on graphs I ever wrote. Obviously, that's Graph Databases by O'Reilly. Buy one. But they showed how graph theory could predict World War I just by making triangles. So they started here at the Three Emperors League, and the black lines are friendships or allies, and the red lines are enemies. And all they're doing here is obeying simple rules in graph theory to make triangles, and triangles form, and unstable triangles evaporate, and eventually you end up here. And in graph theory terms, it turns out this is a stable or low-energy graph. And if you look at it, these are the good guys, and these are the bad guys. And that's World War I. So yay for graph theory. Sucks to be a human in Europe at this point. So graph theory, brilliant for predictions, brilliant for recommendations, and those things are super important to you in finance. What about provenance? You guys do provenance, right? It's a thing. You want to know where your data's come from. You want to know who's operated on it. It's quite complex, right? Did the data come from this database, from this table, from this query, from this guy that ran it? Or did it come from this web service, from this snippet of JSON? Who transformed it? Ultimately, which EJB plus XML system consumed it? You have to know that for governance reasons. You have to be able to supply a provenance graphs to your compliance folks. And no one else gives you an Admiral Akbar. I love you guys, right? It's a graph, of course it's a graph. Provenance is a graph. And it's actually very straightforward to deal with. You know, even though you get really complicated transformations and data flows and whatnot through your enterprise, you can transform that to a graph very simply. Now if someone wants to say, hey, where did this data come from? You simply backtrack through the graph and say, well, some of it came from here and some of it came from here, and this guy ran the query and it was this XML or this JSON and so on. Very, very straightforward in Neo4j. Tell me everything that came from server to at any depth to an endpoint and tell me about it. And you can see you get a bunch of stuff here. Now, obviously, this is a trivial example for a conference talk, but people are building these platforms in their banks right now. There are several in production that I know about. I live in London. There are a lot of banks, they do stuff like this. And it's simplifying their governance and compliance massively. It's no longer a 3-month audit job to try and figure out where this row in a database came from. It's a simple graph query to say, yeah, oh, it came from the mainframe on the 3rd of November, and Dave ran the query. Easy peasy. Word of the day, people. How do you know who you're trading with? Tough one, right? Because corporate structure is difficult. What if you were risk-averse to certain geopolitical events? Let's say you were looking to buy some oil, but you really didn't want to buy from Russia or Syria because those things feel unstable geopolitically. So you buy from Oil R Us SA. Seems pretty fine, right? Seems local, seems European, all good governance and that. But how do you know what their supply chain is or what their governance chain is? And the answer is you don't. So it turns out that often you want to know who your counterparty really is. And it's difficult in today's world because companies are fractal. They're big graphs. Goldman Sachs, for example, isn't one big entity. It's lots of entities that are all aggregated up into the behemoth we know as Goldman Sachs. So what about this guy? What about Portfolio Custodian Limited? Would you trade with them? Maybe. But actually, if you go up the graph and you then discover that Portfolio Custodian Limited is part of Goldman Sachs New Zealand Management Limited, which is part of Goldman Sachs New Zealand Holdings Limited, which is owned by Goldman Sachs Australia Group, suddenly you might be less confident trading with this guy. You might think you could make a profit out of these little New Zealand company, only to find that the big brains at Goldman Sachs have already owned you, and they're spending your money on champagne already. Equivalent problem, thinking about what assets are backed by. If I buy some equities, what's backing that? What if I've got some exotic instrument? What's actually behind that? Same graph problem of knowing ultimately down the line what's backing the price. It's also an equivalent problem of understanding your risk. Right? What risk is in my portfolio now? What's backing the assets that I own? Is it gold? Or is it some exotic thing that I don't really understand? And if you can graph these things, you can actually get your risk position moment by moment, not, as most banks do, at the end of the day. And I liken this, most banks operate as follows. The day starts, they know their position. The day ends, they know their position. They don't really know their position during the day. We accept that from banks for some reason. Would you accept it from an airline? Yeah, like the pilot's awake during takeoff, and then he just kind of points it broadly in the right direction and goes to sleep for a couple of hours. Yeah, you sort of start to, understand some of the inherent risks in this. And, banking isn't some abstract thing. Banking has a very, very strong knock-on effect on us in our daily lives. So we need to know who we're dealing with. We need to know the composition of the assets that we're managing and so on. We can do this trivially in Neo4j because that kind of graph is just a tree. Neo4j can roll up a tree or roll down a tree at lightning speed. You can do this between your web request and web response again, meaning that you know who you're dealing with immediately. You know what's backing your assets immediately. You're not flying blind. Graphs are amazing for understanding opaque structures and allowing us to gain insight into them. This one I'm relieved about. Nigel stood for election. He failed miserably because he's a dick. So lack of governance. One final thing. Swiss leaks. Embarrassing for HSBC. Can you quantify embarrassing? Yeah, billions. HSBC, like any other bank, does not want to be doing illegal things. However, the first HSBC knew about their most people in HSBC knew about their illegal activities was when some data was leaked and the International Consortium of Investigative Journalists, ICIJ, put that data into Neo4j and started to look at the links. They started to follow the path from money through people to accounts and deposits. And by following those dots, joining them together, they were able to present a very compelling case that certain people were engaged with the complicity of some members of staff in the bank in aggressive and illegal tax avoidance. That's taking money from you and me, by the way. Your school that could do with a new computer room, the hospital that needs a new kidney machine, gone because of extraordinarily bad governance at this bank. That breach of trust has cost them dearly, not just directly in terms of the fines that they're going to have to suffer now, but it's cost them in terms of trustworthiness. And if you're in finance, you trade on trust. So what did the Swiss Leaks team do? They took some data that was leaked by bank employees who were worried about illegal activity, some whistleblowers. They put it in Neo4j and they used a tool called Linkurious on top, and they visualized these paths from a legal person through clients into some client profile and ultimately into some bank account secreted away somewhere in Switzerland. By graphing and then visualizing this, they were able to take a bunch of otherwise opaque data in Excel spreadsheets and Oracle tables and whatnot, and turn it into actual evidence that they could use to deliver a social justice program to the bank. The bank did not want this to happen in this way, I'm sure. But the bank could have stopped this by running the same process before the journalists did it. So if you're working in banking and you need to do compliance and governance, which many of you do, You don't wait for the journalist to do this for you. You're already doing it, and your compliance officers are looking at non-compliant patterns, and they're having a quiet word with people saying, this is illegal, we stop it now. Because if we don't, the ICIJ haven't stopped, right? These guys are still going, and they are emboldened by what they have done to HSBC. They took good data, and they did great journalism. They're heroes to me because they are all about the social justice. Oh, and they use Neo4j. Yay. But the ICIJ is like a test tool for business. It's like JEPSOM, the distributed system test tool for business. You should run it on your business to make sure you're compliant so that the ICIJ don't have to. Run the tools before they run it for you. Because you don't want this. Unless you're cold, then it looks pretty nice. You do not want the angry mob beating a path to your door because it demolishes your credibility in the marketplace. So finally, I Googled for Neo4j users, and I couldn't find any more Nigels. But Neo4j graphs, they are not some like weird niche social thing. Graphs are massive in finance, but they're also massive across so many other diverse verticals now, in transport, in social, in education, in navigation, and in logistics, in everywhere. Graphs aren't niche, graphs are everywhere. Graphs are even the logo of Big Data Spain. You should know graphs. If you're in finance, everyone's already doing it. Don't be shy, talk to me. If you want the data from this, happy to give it to you. I can give it to you on a USB stick afterwards. And now that I've already ran substantially over time, thank you very much for listening.